2.1 linear inequalities with one variable. So module 1, we were dealing with equalities. Now we're dealing with inequalities, mathematical inequalities, of course, which is what we're going to keep it as, linear inequalities. So we should only be seeing one variable in our equations. And yeah, an inequality is just a math sentence that compares quantities. Just sometimes the quantity is unknown, right? Like if we were to compare values straight across, hey, 7 and 10, right? Now we would know that 7 is less than 10. So again, 7 is less than 10. That's true. It's just that now, instead of a 7, perhaps they're going to say, look, x is less than 10. Now this is a question, really, of what values are less than 10. And of course, sometimes the first one that comes to mind is 9. 9 is less than 10. Okay, so you could say 9 is x, and that would make that a true statement. Well, what about negative values? Okay, negative values are definitely less than any positive value, no matter if it's 10 or some other positive. What about decimals? What about 9.99? Would that be less than 10? Yes, it would. All right. Now, I'm just pointing out that when we're dealing with inequalities and variables like this, usually that means that there's actually an infinite number of solutions, but they're confined usually within some kind of interval. Okay, and the interval word is going to come back to us. All right, so here's our symbols, right? We got less than, and at least for me, I say, hey, look, it kind of looks like an L right there. So I say less than kind of looks like an L, okay? And then the greater than, I just kind of add a little swoop right there to make it look like a G. I know that's a stretch, but I'll take it, okay? So less than, and the nice thing about these symbols is it makes so that we don't actually have to write these words out. I don't want to, and I kind of hope that you don't want to, which is why the symbols come in play for us, especially with mathematics, which is kind of its own language. And this shows that really the mathematics that we have is kind of based on hieroglyphics, if you think about it, because this symbol means these words right here, which is, I don't know, the nerdy part of me thinks that's cool. The other part of me thinks, man, you nerd. So, but I'll take it. I'll take it. Now, we do have two extra symbols. Perhaps you haven't seen these before. You'll see up here, this one is less than symbol, but this little line down here indicates, I'll use a different color. It indicates that it's also, not also, but or equal to, okay? Because you can't have something that's less than and also equal to, right? So it's either less than or equal to, and when we're comparing values, only one of those has to be true in order for a value to be considered a solution, okay? Which is also true for greater than, right? So this is our greater than symbol, but it also has the equal to part of that. Okay, so like I was saying with the example on statistics, right? They say, well, we interviewed more than 1,000 people. Well, more than, right? More than would be directly, I guess, is the greater than, right? Right there. So it'd say X, that's the number of people surveyed, is greater than 1,000. Again, you could say, well, it's greater than 0 too. What's the difference? But that's just me. So there are different ways to word these. Right, you could say, well, less than, you could also say fewer than. X is fewer than 19, right? And then that would translate into X is, well, less than 19. Or equal to, okay? Well, we'll talk about those here in a second. So looking back, as it turns out, if you can solve equations, you can solve inequalities, no problem. There's only one extra thing that you have to do when you're solving inequalities, and that's, I guess that's what it says down here. But again, addition, subtraction, multiplication, division. We're going to apply those just as we did with equality, so really you can treat it like it were an equal sign. Combining like terms will not, it's not going to change anything, and same with distribution, which you may have to do from time to time when solving these inequalities, okay? But there's just one tiny extra rule again. So solving equations, right, distribute, combine like terms if necessary, use principles of equality to isolate the variable, and then finally the last thing you would ever do usually is to divide by the coefficient. If it's a fraction, you can break that up into two principles of equality, but it's the same thing. And dividing by the coefficient is a principle of equality. It's just dividing both sides by whatever the coefficient is. Well, here's the difference. Solving inequalities, same process. Distribute, combine like terms, isolate your variable. It's just in the end, when you divide by the coefficient, if the coefficient is negative, you have to flip the inequality. That's it. That's the only thing, okay? And we'll see examples like that when we go through the examples for that. It's a really good question. So Inequalities are generally used to, I want to say this clearly without causing too much of a stir, but it's usually to control people. It's usually to control people, right? Like, for example, I just saw an article that they said they surveyed a bunch of people and now they concluded that the American population believes a certain thing, right? Well, you go in there and I was reading the original data and it's like, all they said is that they surveyed more than 1,000 people. What is more than 1,000? Is that 1 million? Did they survey all 200 million, 300 million people? They didn't say. It's just more than 1,000. Oh, it's more than one. What's the difference? You know what I'm saying? So, in my opinion, that's inequalities generally are used. I mean, they're used for more mathematical purposes, but on a real life basis, you'll see that often. We surveyed more than 100 people, and of course, statistics, right? That's usually how you control people's brains, which any marketing major will know. That's use statistics, and then you can control the population. All right, so let's look at this one. We'll translate this into an inequality. I'm not going to solve it, although you could. What the heck, we'll solve it. So it says it's $25 per hour. Your earnings are $25 per hour or no more than 150 bucks. At 25, that makes sense. And so I'm going to take 25. That's how much we make per hour. We're going to multiply that by the number of hours. So I will define the X here. That's the number of hours. And then this would equal how much we get paid, which is showing here at 150 bucks. Okay? Now, I put equals to just because I just got finished with the unit and I'm used to it, right? But it says it's no more than 150. So that's where we got to change this equal now into an inequality. No more. So however much you make is no more than 150. Now, does that mean, well, I guess right off the bat we would say, well, look, however much you make, it's got to be less than that because it's not more than it. Now, when we say no more, does that mean that it could also be equal? Yes, it does. So I would put also that equal part to that. And it looks like if we were to solve this, that means that you'd have to work less than or equal to 6 hours. Okay, and you know, this one, see that positive coefficient there? If I divided both sides by 25, that's how I get 6. But it does not, since it's positive, it just keeps that inequality the same sign right there. Yeah, and that's a good point, because you could write it that way. You could say, well, 150. Again, the main thing here is that we say eat the X. I'm sorry, the 150. It would eat the 150 right there. This is the same inequality. It's the exact same inequality right there. It's just facing a different way, right? Which is okay. Some students are like, hey, we only want to put the X's on the left. Do it. Some people are like, it doesn't matter which side we put the X's on, but it has to be eating the right direction. Okay, so the first one reads 25X is less than or equal to 150. The next one reads 150 is greater than or equal to 25X, but they mean exactly the same thing. Is there? So we just want to see if this is true or false, because remember, a solution should make it a true statement, right? So if I go in here to my 5K this is reading is greater than 35, and I replace the K with 7, right? So that's a 5 times 7 is greater than 35. I'll put a question mark above the inequality there, just because I don't know if it's true or not. Look what happens. 5 times 7 is 35. And then the question becomes, is 35 greater than 35? And the answer here is no, it is not. This would be a false statement right there, okay? But you'll notice on the second example, the only thing that's changed, I mean the letter changed, but the only other thing that's changed right here, 5 times, it's going to be 7, but it's now greater than or equal to 35. But I'm now going to replace the z with 7. Hey, look at this one. 5 times 7 is 35. Now, is 35 greater than 35? No. Is it equal to 35? Yes, it is, which makes this a true statement on this one. This one is true. And so usually students will ask, yeah, but it's not greater than 35, so why is it true? It's because it only has to be one or the other. It can be greater than, like if we said that z was like 100 million, of course that'd be greater than, okay? But then it wouldn't be equal. Okay, you can't get greater than and equal at the same time. Even in number theory, I don't think that's possible, but don't quote me on that because number theory is freaking weird. But yeah, the second one is true, the first one is false because of that equal part on the second statement there. All right, so here's the thing. I know that we haven't really solved an inequality, but I want you to try this one just based on what we know. See if you can get this one. See if you can solve it, okay? 1 minute. Excellent. So, principles of equality, right? And even though this is an inequality, they still apply. So that minus 8 there, I'm going to zero it out to isolate my x. So I'm going to add 8 to both sides. Dropping my 5x here. Negative 8 plus 8, hey, that does zero out. Again, we're not doing anything right now. We won't do anything until the end that may change the direction of that symbol. So it'll just stay the same pretty much throughout. Negative 23 plus 8 is negative 15. Now be careful because some students, even at this point, because it's so new, they're like, it's a negative right there. That's not the coefficient. That's just the negative 15. It's just a constant right there. If this 5 were negative, then I would be looking to flip this inequality, but it's not. It's positive. So keep that inequality the same way that it's facing with the greater than, and we'll divide both sides by 5. Okay, so that becomes x, phantom 1x, now is greater than negative 3. Done. So let's go back to the original inequality, 5x, and we'll show what you're saying here, because it's important to know, right? 5x minus 8 is greater than negative 23. Now, if I go into this and replace x with negative 3, you'll see what happens is that I'll skip the work on this, but we end up with negative 23 is greater than negative 23. Now, this is a false statement, but this is also saying that if you replace x with negative 3, it will be a false statement because this is also missing the equal part of this. But the important part here is that, and this is kind of what we're getting at with the next slide, is this statement right here is saying there's an infinite number of values you can replace x for. Negative 3 is not one of them, though, because otherwise it would need that equal part to it, right? Because we just saw that this created they created an equality, not an inequality. So you could say, well, what values are greater than negative 3? 0 is greater than negative 3. Would that make this true? Yeah, that'd make it true. You'd get negative 8 is greater than negative 23. That's true. Well, let's make it 100. Okay, 500 minus 8, 492. Is that greater than negative 23? Yeah, that's true. So there's actually an infinite number of values that make this true. It's just that this is where it stops being a true statement and it becomes a false statement, which means then if we reversed it, if you looked at any value less than negative 3, the original inequality would then become also a false statement. But it changes where it becomes equal, and that's important to know. The equality part is usually where it will change from being true to being false. So graphing is a nice way to show all of the solutions in a very short span, okay? Now we're going to solve the inequalities the same way that we just saw, just like we would in equality, just in the end, if it's a negative coefficient, we'll flip it, okay? However, when we see just less than or greater than right here, we're going to use open circles at the number where it becomes an equality, right? So that's the important part. And if we see equal to or an or equal to statement, like this one, greater than or equal to or less than or equal to, we're going to use the closed circles, okay? So that just tells us, again, we're looking for the equality part. Where it's equal, we're going to use an open or closed circle at that number. Then we just look, because we hopefully have solved it by then, and see if the inequality eats the letter, right? We say, well, hey, it eats the letter. If it does eat it, then we say anything to the right of that number would make it a true statement. If it does not eat the letter, then the line goes to the left. Everything to the left would make, if you replace the original x with whatever values are to the left of the number, it would make it a true statement. And well, it says to write in 3 numbers. If you're doing it by hand, we shouldn't have to do that. Now the open circles indicate that it's empty, so that that value specifically would not make a true statement, which is why you see these aren't equal to, but we are solving for equality, right? But if it were equal to, like it says here, that's why it's closed. The closed circle indicates that that value would have made the original inequality a true statement, okay? Yeah, so an open circle, yeah, just be open circle like this. Close one, I just draw a circle, I just fill it in, boom. So some people, when they see this, they'll say, well, look, the inequality points the direction of the line. Just be careful, because this will only work, and I know I haven't shown it, but it will only work if you always keep the x's on the left. Now, there will be times where that's super convenient. There will be times where that's inconvenient, which is okay. You can still do it. It just creates a couple extra steps for you. But sometimes you may want the x's over here, in which case, yeah, the inequality means something different. These two are meaning something very different, right? X is less than some number. Right here, we're saying that some number is less than x. Very different. All right, so let's just practice graphing. And we're not going to worry about the principles of equality on these, right? And, well, I guess it'd be nice if the numbers lined up with the lines. We did the best we could because computers, I blame it on the computers, but it's more me. In any case, all right, so I'm going to start with number 1. X is less than 4. Okay, now we're going to graph this. I'm going to say that this line is 4 because the 4 didn't really line up very well. Thank you, Mr. Sal. But that is less than 4, which means that 4, it would not be a true statement. I'm just going to keep an open circle there. Okay, so I start with the circle at the number. Of course, if x were 4, it would be equal, but it would be a false statement then. Now I would say, look, the inequality is not eating x. So for me, I would drive this line to the left. Boom. And so any numbers to the left of 4 there, again, if you replace them into the inequality, it would make it a true statement. Okay, so that's number 1. Number 2, x is now greater than 4. So it's not equal to 4. So at 4, I will put an open circle again. This one, however, is eating the x, which would make the line go to the right. Now, there's different ways to show the line. Well, I'll show this next one a little bit differently. Number 4. I don't know what happened to number 3. Sorry about that. But this one is less than or equal to 4. And I'm gonna put the 4 right there. We'll pretend like we didn't see that one. At this 4. Okay, now you're going to need a circle at 4. But this one, since it's equal to, is going to be closed circle. So you see I'm just coloring that in. And, you know, if you really want to make it colorful, grab some crayons. That's fine with me. But this one is not eating the x. So like I said, some students will show this different. This is what I've seen in the past. That's fine. I mean, when you're doing it by hand, right? Now, on the computer, what you'll have to do, so I'll do this with number 5 like the computer, okay? So below, they would say you got some options. You got an open circle, you got a closed circle, and then it'll have a line tool. I think it looks something like this, okay? So you'd have to click first on, because this one, it's equal to, right, at 4. So, and we'll say this is 4. On the closed circle one. So you click on this, and then you'd have to click at 4, and then it will just magically appear, boom, a closed circle there. In fact, sometimes I think the lines are connected to these, so it may look something like this, or this one's something like that. Okay, so you choose the closed circle one because it's equal to, and then you'll have to drag the mouse whichever direction it needs. Now this one's eating the x, so I'm going to have to drag the mouse over here. Now if you drag the mouse here, it's going to stop right there. If I remember right, it's going to stop right there. That's false. Because we need to see everything that is to the right of 4, which means, see how these other examples, we got the arrows, right? We need to see those arrows. If you don't do that on Canvas, it will mark those incorrect. So make sure you drive it to the right until it shows the arrow. Then you're going to click the mouse, and then it will keep that arrow there for you. The open circles, the closed circles, and then again, which direction the line goes, those are all the numbers you could replace in the original inequality to make it a true statement. But notice, again, it even covers the numbers in between. So like this one right here, this interval right here, what is that, 5 and 6? So 5.00001 would work. That would make this a true statement. Or 5.99999. That would make it a true statement. So even the decimal values will work. So let's switch this around. We get the graph. Now we're going to write the inequality for this, okay? So I'm going to use x. I'll put x on the left. Not that it matters. In fact, I'll do both. Okay, so I'll put x on the right. This is going to be the same inequality. It means the same thing, just shown differently. Now, the first thing I would do is notice the circle. See, this circle right there is closed, which means that it's going to be an equal part of the inequality, right? Because it's a closed circle. If it was open, it wouldn't have that equal part. Then I see that this line is going to the right, which would mean that the inequality would need, I put that on the wrong side, by the way. It needs to eat the x. Okay, so for both of these, the first one here is going to eat the x that's greater than, or down here, it's a less than or equal to x. Okay, but again, they mean the same thing. And then we see what number are they comparing? Hey, it's not -8. So for both of these, we just put -8 on the opposite side of the inequality, and it's done. Once again, either one of these would work. Usually, most students would show this one. But again, either one would work if you're doing it by hand. All right, we're going to go ahead and solve this one, and then we're going to graph the solution on the number line. We'll go ahead and use the same principles of equality that we have been using, but we'll remember that final step, right, if it's needed. So the first thing I'm going to do here is isolate my x's. So these two x's, I would like to just drop them as is, but not add or subtract anything to it. So that +8 has to go. I'm going to zero it out by subtracting 8. But if I do it to one side, I must do it to the other side as well. Of course, this will not affect the inequality here, but 24 minus 8, that's going to give us 16 there. The last step is to divide both sides by the 2. If the coefficient were a negative, I would flip that inequality, but it's not, so I don't. So I get x is greater than 8. Now I'm doing this graph by hand, so I just need 3 marks on it. In the middle, I'll put where this was essentially equal, right? Because we solved it like it was equal. And then 1 to the left would be 7, 1 to the right would be 9. And now at 8, I would have an open circle, because again, it's not equal to the 8, it's just greater than. And that will give us the open circle. Then to figure out the direction of the arrow, we just say, well, it's eating the x. When it eats the x, the line goes to the right, and that's done. I will do this one though, okay? So let's graph this one. And it says, yeah, we just want the regular solution here. So -3w is less than -39. Let's go and divide both sides by -3. Okay, now, common mistake here. W is less than 13. The number's correct, the inequality is incorrect. What happened? Well, we had to flip it because the coefficient was negative right there, which should have flipped the inequality. So this W is now greater than +13, okay? Now I'm doing this graph by hand, so kind of like what it said. It'd be nice to have 3 values. The one in the middle should usually be the number that makes it equal, so I'm going to put 13. To the left would be 1 less than that, it's 12, and then 1 to the right is 14, okay? You won't have to do these by hand on Canvas, but on a test or an exam, you may have to. So this one, open or close circle of 13, it's open because it's not equal to 13. This one is eating the W, which means that it goes to the right. Done. Not only did we get the graph, but the inequality as well. If you wanted to, you could say, well, look, I'm just going to test. I know it's equal at 13. I can test 14. Oh, see, that would be a true statement. -3 times 14 would be -42. That would be true. If you put in 12, then you'd find it would be a false statement up there. Yeah. All right, this one just says to solve the inequality, so we're not actually worried about the graphing part. That's okay. You'll see that on the homework from time to time. -14 plus 10k is greater than or equal to 13. And again, I just want to isolate my k's there, so I'm going to get rid of that -14 by adding 14. That'll be 0. It will zero that out. It allows me to drop my 10k's, which now is greater than or equal to 13. That should have been plus 14. Sorry about that. 13 plus 14 would give us 27. Then finally divide both sides by the coefficient. Again, at this division phase, if that were a -10, I would flip the inequality, but it's not, so I don't have to worry about it. My final answer here ends up being a fraction, which is okay. Having a fraction here is not a problem, especially when we're just solving for the inequality. No need to graph this, no need for interval notation, it's just done. Same thing on this one, it's just this one is asking for the graph, and there's not a problem with that. this is a two-stepper, just like we would with a regular equation. I need to isolate my three x's, so I will be subtracting 4 from both sides to zero that out. This now drops my three x's, which is now greater than or equal to 16 minus 4, which is 12. And now I will divide both sides by the coefficient 3 to make that a phantom 1x, which is now still greater than, again, that 3 is a positive there, so I don't have to worry about flipping the inequality, but 12 divided by 3, yeah, that's going to give us 4 right there. So x is greater than or equal to 4. Now I'm going to go to my graph, and right in the middle I'll put the 4. That's where x would be equal. 1 to the left is 3, 1 to the right is 5. And with positives, this is pretty consistent, and I think that kind of makes sense for us. It's when these are negatives that you got to be very careful, right? Because if this was negative, the number to the left would be a bigger negative. The number to the right is a smaller negative. That's because numbers get bigger as they go to the right, and you'd want less negativeness as you, well, I guess as you go to the right. Okay, numbers to the left would be more negative. That's one way to put it. Now for this one, x is greater than or equal to 4. The equal part of that inequality is going to make this a closed circle there. And then this one is also eating the x like the last one, so this line will go to the right as well. So interval notation, it always helps me. I would like to think that it helps everyone, but it helps me to see a graph on these. Will it always ask for a graph? No, it won't. But again, I make the graphs because if I can visually see what the solutions are, then it will help me with interval notation. I'll explain that here in a second. But so the interval notation and the graphs, to me, they're directly related. The only thing that we have to understand with interval notation is we're going to use regular parentheses to indicate that values are not true in the original inequality, which means that the parentheses would be for less than or greater than symbols, okay? If you use the brackets, that's like a closed dot, which means that the values would be equal to, which means that these would be related to less than or equal to or greater than or equal to. Okay, so if you see just less than or greater than like this, you will be using regular parentheses for these. I know it doesn't make sense now, but hopefully it will, okay? And then brackets for inequalities that include equalities in them, right? Now the interval, like I said, it's related to the graph. I feel like the more I explain this, the worse it's going to be. So I'm going to show an example, okay? So here's an inequality. Let's go ahead and solve this one. And for me, I would personally say let's put the x's on the right so that we don't have to deal with the negative coefficients. But I've been told in the past, let's just keep them on the left. All right, whatever. It doesn't matter to me. So, well, it may add some steps. That's not a problem. I will do this 2 steps in one, okay? Because I'm not worried about our final one-step equation, whether they're negative or positive right now. I just want to isolate the x's first. So for me, since we're putting the x's on the left and the numbers on the right, I want to get rid of that plus 2 by subtracting 2 from both sides. So that zeroes that out. Negative 2 minus 2 is negative 4. Then I will also subtract 13x's because it's on the number side of things, which then makes that negative 9x, appears. So negative 9x is greater than negative 4. Okay. Well, the last thing we would do is to divide both sides by negative 9. But because that coefficient is negative, it will flip the inequality to less than. So now I get x is less than, well, positive 4/9. And even though that's a fraction, that should be okay. It didn't ask for the inequality. I mean, it told us to solve the inequality, but we want the interval. Okay, so like I said, let's go to the graph here and see if we can make this work. So right in the middle, I'm going to put my 4/9. Yeah, we can put fractions on graphs. In fact, to the left, I'm going to put 3/9. Why not 1/3? Because I just want to deal with ninths. Okay, and I'm doing this by hand. Even though when you do it, you won't have to do it by hand. So there's 5/9 to the right. See, one less, one more, one less to the left, more to the right. And for 4/9, since it's not equal to 4/9, I would put an open circle there. And this one is not eating the x, which means that the graph would go to the left. Okay, now like I said, this did not ask for the graph. I just think that having the graph will help us to determine the interval notation. Now, I say start from the left and then scan to the right. So for me, I would say, how far to the left does this line go? Now, some of you say, well, it would go into the trillions or the quadrillions or whatever the heck. It goes really to negative infinity. What the crap is negative infinity? I don't know. In fact, there's only one person in history that we know that has counted to infinity. That's Chuck Norris.
Yeah.
But Chuck did it twice, which is pretty cool. Now, at negative infinity, since mathematically we can't quantify it, we have to say that it's not actually a solution because we don't know what number it is. It's so big. Well, then, like I said, we scanned this to the right. So I started at negative infinity, which would go to the end of the arrow. And then I scanned to the right. Where does it stop? Boom, 4/9, right? So I put comma, 4/9. And then is 4/9 a solution? No, it is not, which means I would also use parentheses. If this were to have the equal part to it, then I would have used a bracket right there.
Oh,
You can never use brackets with the infinities, though. Whether it's negative infinity or positive infinity, you cannot use brackets because it's an undefined value, mathematically speaking. We just don't know what it is. It's so big. Now, you'll notice with the parentheses that it closes this set of parentheses right here. That's important because later on we're going to look at compound inequalities, which will tack on extra parts, extra intervals for us in the future. All right, so on this one, make sure you don't put another open parentheses right there because it needs to close that gap. This is the interval. This is a nice quick way to say what the graph is saying, but I hope that makes sense why the graph is a good way to get to this interval right here. All right, here's another inequality, and this one has some distribution. That's no problem for us. We can distribute into a set of parentheses, right? That's 4 groups of x, which would be 4 x's, and then also 4 groups of -2, which would be -8 right there. Nothing else changes on this, but now we have gotten rid of the parentheses. We need to isolate our x's, right? So just principles of equality. I'll do this just really to save space here. I'm going to put my x's on the left, and then the numbers will be on the right, so that -8, it's got to go. I got to add 8 to both sides. That will zero out that -8. Now I'm not going to drop my 4x because I'm going to work with my 3x as well. I'm going to subtract 3x from both sides because it's an x term right here on the number side of things, so I got to zero that out as well, which it does. 3x minus 3x is 0. So what am I left with? 4x's minus 3x's, that'd give me 1x's. Nothing we've done would change the inequality. And then 5 plus 8 is 13. So I get x, really just x is greater than 13. You could say divide both sides by 1, but that's not really going to make a difference. So I'm ready now to put 13 right in the middle on the graph. To the left would be 12, and then to the right would be 14. I know those are not spaced equally, but I don't really care at this point because I'm doing this by hand. So right in the middle is 13, right? So that's an open circle because it's not equal to in the inequality. This one is not eating the x, so also this line will go to the left. Now you'll notice that this one is asking for interval notation. Well, we use graphs to help us to write interval notation. And we would say, well, how far to the left does this blue line go? It will go all the way to negative infinity, which is never actually included. So we have an open parentheses right there. That's as far as left as it will go. Well, we put a comma there, and then where does this end? It ends right at 13, okay? Now, if this is an open circle, as it is, we would need to use a parentheses here, which I will do. Close the parentheses. If it were a closed circle, because it was equal to, then we would use a square bracket there to indicate that 13 would then be a solution to our original inequality. But for now, this is all we need. From negative infinity to 13, both of them are not inclusive. All right, we'll graph this one, we'll solve it, and then it looks like we want this one in interval notation as well. No problem. So I'm going to isolate my negative 6x's by adding 10 to both sides of this inequality. So that will zero that out just like we want. So now I got negative 6x is less than or equal to 8 plus 10, which is 18. And then I will divide both sides by negative 6. Now at this point, you've got to be careful because we do get a little conditioned to just keeping this inequality the same, right? Then you'd say, well, 18 divided by negative 6 is negative 3. And that's true. It's just the inequality, right? Since we divided both sides by negative, another way to put that is since the coefficient of x was negative, it should have flipped the inequality, okay? So the negative out here and we divide by the negative, that's going to flip this inequality. So now x is greater than or equal to negative 3. And that does solve the inequality there. But now I'm going to go ahead and put it on a graph because it did say to put it on the graph. And so right in the middle there will be negative 3. Now this is where I said you got to be careful with those negatives. To the left will be a bigger negative, so that's negative 4. To the right will be a smaller negative, negative 2. So at negative 3, we got a circle, but this one's going to be a closed circle because it's also equal to negative 3. So that indicates on the graph that negative 3 is a solution. This inequality is eating the x, so it will also go to the right. So that's my graph, and now I'm ready to write this in interval notation. So as far to the left as we can go with that line, it will start at negative 3, right? Now that's a closed circle, so I'm going to have to use a bracket there. So as much as my handwriting stinks, hopefully we can still tell that's a square bracket. How far to the right does this thing go? It goes all the way to infinity, which is never included. So this right here is our interval. And again, I pretty much use the graph to write the interval out. Of course, when you put this into Canvas, you'll have to notice the difference between a square bracket and a regular parentheses. All right, let's take care of this one. And one of the problems we see a lot on this type of problem is this negative business right here, okay? Because students are like, well, it's just a negative 7x minus 6. No, we do look at this as a negative 1 that I then need to distribute into the parentheses. You want to keep that in mind because it's a common mistake, which we wish we didn't see as teachers here. So that's negative 1 times 7x, just negative 7x's. And then also negative 1 times negative 6, that would be positive 6 right there. And that's one of those things, and a lot of students put a minus right there because they forget either the 6 is negative or the 1 is negative. Now that's that one set of distribution, but we also have this one over here. That's 4 groups of 3x's, which would be 12x's. And then also 4 groups of negative 4 would be negative 16. So to write this all out, I got negative 7x plus 6 is less than or equal to 12x minus 16 minus 2. Now I'm ready to combine any like terms, which I do see between negative 16 and negative 2. Those are the only two like terms that I see. And when I do combine them, I'll get negative 18. Nothing else will change in this equation right here. Okay? So that's what I have now after combining like terms. Now, let's see. Yeah, I got some space, so I guess I'll do this in 2 steps, although you could do it in 1 step if you'd like. I'm going to keep the x's on the left, and that's kind of on purpose right here. You'll see why, but you don't have to. You can put them on the right if you know why, if you have a good reason for it, and most students do. Most of you may look at this and be like, I'm putting the x's on the right, and that's because, well, I guess that's kind of a spoiler alert here, but you do that because you want the coefficient to be positive. I don't really care about that, and I'm going to do it on purpose so that we're going to have purposefully a negative coefficient. But your answer in the end should be the same. So I want to isolate my x's, so I don't want that plus 6 right there. I'm going to have to subtract 6 from both sides to zero that out, which it does. And now I got negative 7x is less than or equal to 12x. But negative 18 minus 6 is going to give me negative 24 there. Now I will get rid of the 12x because it's on the number side of things, so I'm going to subtract 12x's from both sides of this inequality to zero that out. Negative 7x's minus 12x's is going to be negative 19x's. Now is less than or equal to, we'll drop this. Again, it's not that it's negative, it's not that it's positive 24, it is negative 24. That's important to know. And then finally the last step here is divide both sides by the coefficient, negative 19. So we do end up with a fraction right here. That's not a problem. We end up with x is less than, oh, I apologize. Yeah, see, I almost did that right there. I divided both sides by this negative, so that means that I should go in and flip this inequality, okay? That again goes back to the negative. Negative 24 divided by negative 19. I'm just going to keep that as a fraction. I think the decimal there would look really ugly. So I didn't see that this one wanted a interval or the graphing, so I'm just going to keep it like that. And we'll call that good right there. All right, this one wants the answer here in interval notation. No problem. I will graph it, though. Again, I like to see the graphs just for visual representation of what the interval is. So let's go ahead and solve this one. Okay, so I can do this in 2 steps. I'm going to put my x's on the left and the numbers on the right. So that positive 45 is on the wrong side. It's on the x side of things, so I'm going to have to subtract 45 from both sides there. Okay, so that does zero that out. I will drop my negative 5x's, which is now greater than, yep, we'll drop the 10x as well. And 75 minus 45, that's going to be positive 30. So plus 30. Then I will subtract 10x's from both sides because, again, those 10x's are on the number side of thing. So that's going to zero that out. Negative 5x's minus 10x's, negative 15x's. And this is greater than, I'll drop my 30. Some of you, again, you may have said, well, I'm going to put all my x's on the right, which would have been fine. It would just show a little bit different, but your inequality would be the same. Lastly, here, I'm going to divide both sides by the coefficient negative 15, which will give me x. But now, the negative there is going to flip the inequality from greater than to less than, and 30 divided by negative 15 is going to give me negative 2 there. Okay, so I have x is less than negative 2. If, by chance, you had solved with the x's on the right, you would still get x and negative 2 compared, but now it would be negative 2 is greater than x. These mean exactly the same thing. Okay. So now that we have that, we have the inequality. Let's go ahead and look and see what the graph will look like. So I give myself a line, and the graph will help us to find the interval there. So right in the middle is negative 2. Since it's negative, to the left will be a bigger negative, and to the right is a smaller negative. Got to be careful with those negatives because that's a common mistake we see not only on exams but quizzes and even the final from time to time. So at negative 2, it's open circle because, again, it's not equal in either case. It's not equal to negative 2. And in both cases, we see that it is not eating the x, which means that the line would go to the left. Now, it didn't ask for the graph, but again, I do the graph because it helps me to visualize what the interval will be. How far left does that blue line go? It goes all the way to negative infinity, which is never included, so we have a open parentheses there. All right, well, where will it end? Well, as far to the right as we can go is negative 2. And that's an open circle there, so I have to use a parentheses. This here is the actual answer they wanted from the beginning because they did say they wanted interval notation. So that's it.
Now, usually I'd say on a problem like this one, use cross multiplication by just making the 5 over 1. I'm not going to do that, though, because we don't really need it. And so on this one, geez. Here's the thing is, you could split this up. And I'm not going to, but you could. You say x over negative 2 minus 30 over negative 2 like this. Okay, now that becomes really confusing. So again, I'm going to skip that. But the important thing that you notice here is that the coefficient, that's being multiplied really by negative 1/2 right there. So when I go to solve this one, I would multiply both sides by negative 2, okay? And since I did, this is the principle of equality with multiplication or division. With the negative, to make this a phantom 1, it flips the inequality right there. So you got to be careful on these, okay? So now I get x minus 30 is now greater than negative 10. Then I add 30 to both sides. That solves it pretty quick, right? So plus 30, x now is greater than 20. All right? So it says write the answer in interval notation. I'm going to use the graph to help us with this. So there's my graph. I'm doing it by hand, so sorry if it's getting a little sloppy. At 20, open circle, because it's not equal to x, but this one is eating the x, which makes the line go to the right. And again, I'm just using the graph to make our interval. Since it's not equal to 20, I'll use an open parentheses, starting with 20. This one goes how far to the right? Infinity. And never use brackets with infinity, so it should be closed parentheses like this.